3.6, calculating higher order derivatives. So, if y equals this, I want this. What does this mean? This means the second derivative. This means the derivative of the derivative. So we're going to take the derivative and then take the derivative again. This is actually very important for the next chapter called concavity. There's an application called the second derivative. There's also, there's some interesting things and very important things about second derivatives we'll be talking about. So here's how you do it. You first take the first derivative. So y prime equals, okay, take the derivative tangent. Tangent is secant squared. Leave the inside. Take the derivative of the inside. Are you okay? That's the first piece. So I took the derivative of that. Now I'm going to take the derivative of this. So I have minus. ln will be u prime over u, I like saying u prime over u. It's an old way of saying it, but what you're going to do here is you're going to put the 3x on the bottom and take the derivative of 3x and put it on top or behind it, which that does reduce. So again, I put 1 over 3x and I multiply by the derivative of 3x, which then just goes on top. Anywho, so that right there is the first derivative. Let's clean it up before I take the derivative again. Before I take the derivative again, let's clean this up. So that's 2x times secant squared x squared minus 1 over x. We don't have to get common denominators. That'll make it ugly. Actually, I'm going to clean this up a different way. I'm going to change this to be x to the negative first, because that's easier to take a derivative of. X to the negative first is easier than 1 over x to take the derivative of. So here's what we do. We're going to take the second derivative, and I'm going to use this sign. So instead, these are both interchangeable. These two signs are interchangeable. Second derivative, 2 little tick marks. These are the same. So I'm going to use this one instead. I just like it better. It's easier. All right. Do you see here a product rule? Do you see a product rule here? So that's going to be 2 times, leave the secant squared, x squared, plus, leave the 2x, and take the derivative of secant squared. This is a double chain, or the repeated chain. So be careful here. You're going to put the 2, leave the secant x squared. All right, so 2, leave the secant x squared. Now take the derivative of secant x squared. The derivative of secant is secant tangent, so that's going to be secant x squared times tangent x squared. And then you take the derivative of the inside. The inside of that is going to be 2x. So that is an ugly chain right there. All right, and then we still have to take the derivative of this. So the derivative of that is simply going to be, it's going to be a negative, but you bring the negative out front so it becomes a positive, and you drop the power by 1. So if I drop the power by 1, negative 1 minus 1 is negative 2. There's my last little piece. All right, and then let us clean this up slightly. Let us slightly clean this up. And let me actually switch it. I'm going to switch the notation now, just so you have the notation that was written at the beginning instead of y double prime. All right, now I could pull out GCFs, but I'm not. I'm just going to put 2 secant squared x squared. Okay, now this one right here is a mess to clean up. Do you see all that? That's a mess. I have a 2 times a 2 times a 2, and an x times an x times an x times an x there. So what does all that give us? That looks like it gives us plus 8 x squared. And then I have 2 secant squareds. So I have secant squared x squared. And then I have the tangent x squared. And then I have the plus 1 over x squared. And that I'm going to leave as my answer. Now technically, could I try to get common denominators by multiplying all of this, these two pieces? Yes, by x squared. I could keep going in common denominators. I'm going to stop right there. Let f be the function right here. What is the instantaneous rate of change of f prime at x equals 1? Now listen carefully to that. You want the instantaneous rate of change of f prime, not of f. So the instantaneous rate of change means derivative. I want the derivative of f prime. So what this is really asking for is this. I want f double prime at 1. That's what it's asking for. I want the second derivative. I want the derivative of f prime at 1. That is the question. So how do we do that? Well, we go up here and we start by taking the derivative of that. And I would probably rewrite that as this. I don't want to do a quotient rule. I'm going to rewrite it as that. I don't want to do a quotient rule in that last part. I'd rather make it a chain idea. Kind of, not really a chain, but a negative x power. It's not a chain. So the first derivative, let me get rid of that tick mark, is going to be, well, e to the x squared. Those are pretty easy. It's just going to be e to the x squared times the derivative of x squared, which is 2x. All right, that's going to be minus, actually it's going to be plus 6x to the negative third. The reason for the plus is this negative 2 multiplies by that and drops the power by 1. And that right there is my first derivative. Now I take the derivative again. That's what its higher order derivative is saying. Let's take the derivative again. That means 2 little tick marks, 2 primes. So do you hopefully see here a product rule? Do you see a product rule there? So we have a product rule. So the first piece of the product rule is going to be e to the x squared times 2x. All right, that's the first piece. Leave the second piece, plus, leave the first piece, times the derivative of the second piece. And then we're going to take the derivative of this, which is negative 18x. Remember, when you drop the power by 1, that's a negative fourth power. Okay. Now, we could simplify this, or we could just plug in the answers where they're at. Not plug in the answers, but aren't we going to be plugging in 1 now? Don't we want to find at 1? So I'm just going to kind of plug it in and clean it up at the same time. So watch this. This is going to be e to the 1 squared times 2 times 1. This is 2 times 1 plus e to the 1 squared. 1's pretty easy here, huh? Times 2. Minus 18 over 1 to the 4th. Now you might have got tricked up what I did there, but doesn't negative power bring it back to the bottom? It's kind of hard to calculate a negative power. You have to rethink what it means. The negative power goes back to the bottom. So here we go. Let us clean this up some more. So the second derivative at 1 is equal to 2 times e to the first is just 2e. Times 2 plus e 1 squared is 1. E says the next one is just 2e. Minus 18 over 1 is just 18. Okay, so let's keep cleaning it up here. Won't that leave us 4e plus 2e minus 18? And what's 4e plus 2e? Isn't that going to be 6e minus 18? And that is my final answer right there.